about to move on to part 2 of day 3 in Advent of Code. So I just wanted to... so basically I'm back. If I go to the website, I still need to input the answer to go to part 2. So let's do that. The task was basically overlapping wires, and I had to show the overlapping points and get the point closest to the end. And oh, it's the second one. Okay. And the point right now that I need to do is to find the distance, the overlapping point to which both wires will come the closest, I think. So let's read it again. It turns out that the right circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes to reach intersection. Yeah, calculate the number of steps. Choose the intersection where sum of both wire steps is the lowest. If a wire visits the position of grid multiple times, its steps value from the first time it visits that position when calculating the total value of a specific intersection. What does that mean? If a wire visits a position on the grid multiple times, so basically if I take this, so I would need to take a sum of these, yeah, and a sum of this. $20. 8 plus 5 plus 5 plus 2, 8 plus 5 plus 5 plus 5 plus 2, and the other one 7 plus 6 plus 4 plus 3. Good. So I need to calculate the shortest path for both. Let's do it. And I have a test which is failing right now, so I need to implement the solution that will fix the test. And the test is called is it a panel test? It's not a panel test. It's crossbar test probably. Find tangles, calculate short distance to origin. I don't remember what I wrote. So let's just run again the test and see which one failed. And the one failed is a wire test for return expected distance. Right. It's the wrong name. Valid wire returns expected shortest. Oh, expected distance, a single distance. Right, so I'm calculating a distance on a wire. And get length is 0 right now. Yes. So it's a bit ambiguous, so I'll rename it. Expected length of wire. Good. So I create a wire from paths, and the paths are these. And now I need to get length. And getting length is really easy. I just do a for each to every path and calculate distance in between. So well, I start from the origin point, and I don't remember if I include the origin point in the path, probably not. For each var point in path, yes. And I say var distance is 0, var previous point is origin point. So we start at origin point, and then the points in the path are the points after it. And then we say distance. We need to calculate distance. Do we have a distance between two lines? Point, line test. That's a test, and I need line intersect, plot. I need a distance. Public int get distance. Static int get distance point 1 point 2. I can make this an extension method, no problem. Probably, yeah, there's a problem, okay. So if in a line, oh, it is a line. Oh, okay. So whatever, I'll create a line, and if orientation is vertical, if it's horizontal, then I return so if it's horizontal, I return absolute value of, in any case, I return absolute value. Distance is int distance, and distance is start x minus end x, else distance is start y minus end y, and return math apps distance. Good. And if I go here, get length, we need to take the points and build a line. So I take a previous point. To build a line, I take a previous point, and then I take this point. And then I say distance is line get distance. And then I say previous point is this point. And then in the end, I return distance. Let's see if it worked. So now I have a way to calculate distance in a single wire. And it works. And now I need to find the longest distance. The longest distance is quite easy, but I need to find the point closest to both, and that will be a panel thing. So public void panel. At the task we have these inputs. So they will serve me. But I should make one simple one first. Day 3 was not solved already because there was still part 3 not done. So I'm wrapping it up. Roll off and hello. Alright, so panel. With valid wires returns what returns? Find shortest path to shortest find shortest closest intersection point to both returns expected point. Theory. And then we say we will be taking what we will be taking probably some config file. Or how do we initialize panel? We can initialize it through a panel config. So we'll take a config file. Returns expected shortest distance. And right. For the 6th, I actually pictured quite poorly. I really would like to have this one on. And this one is this. I'm lost. I'm lost. Okay, this one. So it's 6 that it returns, right? No, it's 40. For both. So I need the sum, not the shortest, but sum. Returns, find closest signal, find shortest signal, calculate shortest signal, returns expected value. Good. Now I need to place that if I didn't already. I think that's the one. Tangled wires, distance 6. Tangled wires, distance 6. Yes. So I'll read this one and I'll read the other one. So the first one I read is this one. Second one I read this one. And then there are 2 extra. Are they not from this one? 72, 72, 83, 83 are 7, so I can read those 2 as well. But the answers will no longer be that. Calculate shortest signal sum. Returns expected value. So what's the value for the first one? Well, for this one, we actually have it calculated for us, and that is 40. The first wire takes only 15 and 30, so 45. And for this one, we have right, up, left. So we have a single point, and a single point returns. So this is already apart. So 1, 2, 3, 4. Literally it. So this one returns 4, this one returns 45, and about those 2, 610, 410. 35 is R51, so, and R7. R51, I'm confused. 51. So the bottom one is this. Okay. Double checking. So 59, the one with distance 59 is the shorter one. The one with distance 59, 8372 is 610. 59, 610. Good. So we have our test done, and now we say that we create a new panel, basically exact same thing, except the method that we call will now be different. Calculate signal closest signal sum to intersection. Read along name. Calculate signal sum signal distance to closest intersection. Too long, way too long. How to make the name shorter? I cannot think of a better name, sadly, right now. So we do it's an int. We do a for each var. How do I go about this? I first find all tangles. So I find all the tangles between my own wires. And then I say that I take each point in a wire that is a tangle. No. I say that I take the origin point and I calculate the path to the tangle for each wire. So I need a way of calculating path up to a certain point. So wire 1 path, that's our path, and the tangle is index of this point. I wonder, does it work? Cannot apply indexing with so I have my tangles and now I need to okay. So I say var I'll need another test. Do a TDD, return 0, test fails, and I'll move on to another one to calculate a path up to a point, a distance of wire up to a point. Okay. Why is it saying something is missing? Really don't know. Oh, I have a symbol there. That's not needed. Okay. Okay, good. It was supposed to fail. 4, but found this. Yes, good. So I'll skip this for now as we move on to the one with the distance. So I need to calculate a distance in a wire up to a certain point. Yes. And start, end. And I basically need all points plus 1, the end point on the path. Wait, I have all the points. Okay, I have all the points. So I can, yeah, I can determine the distance. Good. Get length, public, int, get sublength. Get length to point. Calculate, not get. And this is calculate as well. So I say var distance. I'll actually move this to there. And this will be deleted. And this one will be, I calculate up till the last point. So that's quite easy. So calculating total length would be calculating length from the start till the end. And I have a function which can calculate a length to a given point, and that point will be the tangle point. So tangle point. So previous point, point and path, line, distance, previous point, perfection, but I need to find the point which is a stopping point. And that's quite easy actually. Can a wire cross itself? It doesn't matter. If it does, I stop anyways. So if after the distance calculation I am at the point that I need to be, so if my point that I am at the moment equals to the tangle point up to which I calculate my distance, I stop the loop. Else, I continue until it's the end. So, and then I return distance, and then it's good. Good, so now I have an algorithm to calculate distance up to a point. And now I have all intersections, tangles, and now I need to find closest tangle, shortest distance to origin. I need to find distances. So for each var tangle in tangles, I need to calculate distance from origin till cross section for both wires. So so wire 1, calculate length to point this tangle, and var signal steps 1, var signal steps 2. Whoops. And then I say sum. And at the same time, not at the same time. And then I say sum is my goal is to find the shortest distance. So var closest intersection signal, closest signal distance is 0. Closest signal distance is the sum of both. Total signal steps is the sum of both. And total signal steps, plural, is this. Closest signal distance will be pretty easy. If total is less than closest, so the first one needs to be very big, maybe int max. So if the one sum that I calculated by blindly shooting is less than the one that is at the moment, we change the value of the smallest sum of the shortest distance signal length. So total signal steps. That's it. And in the end, we return closest signal distance. Let's run it. Sadly, 516, 916, 36. I'm missing something. 916. Why this one fails though? Expected distance to be 45 but found 36. This is the one I'm most interested about. So let's debug it. All right. So we have two wires, we find tangles, we know that this one works, so we skip it. Then closest distance, we calculate distance to the first point, which is 6 and 5, 19, the other one 17, and we get 36. All right, so why did it calculate stuff length to point? I didn't implement the algorithm to do that, the test to do that though. Previous point to a path. Previous point is a point. So line which starts at 0 and ends at 1, 0. Distance is 1. Okay. And this one, a line that starts at 2, 0 and ends at, starts at 1, 0 and ends at 2, 0. What? Oh yes, because I plotted. Oh, I plotted. I plotted, so I might do it a bit differently. It's literally amount of points up to that point and not a sum of the lines. So I don't need this one. I don't need that one at all, actually. And instead of this, I can just give a number of points up to that point. So for each var point in path, var point, var steps, var distance. Distance is 0, distance every single point plus plus. And that's literally it. Every single point distance is 1 because I plotted it 1, 1, 1. So if point is a tangle point, break, that's pretty much it. So calculate length to point. I would like to have a test for that too. Wire test. Valid wire returns expected. Valid wire length to point returns expected length. And width length input. Width point of wire input. Good. So we will take 3 things. Literals. So path, a point that indicates up to which point we're calculating it. So left 2, we can calculate left 2. So it goes 2 to the left. So it's -2, 0. And we can calculate that. And -2, 0, the length will be 2. This one goes left 1. This is a boring one. I'm not interested. Left 1, more like left 2. Let's say left 2 again, so it's -4. Let's say down, no, up 2. So now it's 6. And I calculate the point. Sorry, it's 6, but I will not calculate it till the end. So it will be till the point called left 2, left 4 now in total, up 2, so -4, and up 2, but I won't go till the end, 1. That's it. Comma. So this test now, I call it this, and I will call it here. So if I call it, if I run it, will it give me the right answer? No, but that's a good thing. Oh, because I forgot one more parameter. So we take in a path, a point, and expected length. Okay, so I have a flaw in calculating length. Why? Expected length to be 2, but found 4. Expected length to be 5, but found 6. Wow, interesting. Expected length to be 2, but found 4. How? How is it finding 4? Oh, no, it's still 4. It's actually irrelevant. I don't need this actually as well. Point in a path. 4 points in a path. So it never... -2 and 2. It should actually return a distance. Return the distance, else throw no tangle, not a point on a path exception. I don't think I have that one yet already. Point not belonging to wire exception. It's an exception. Public point not belonging to wire exception. And we pass in a point. And we say, whatever. And we say point I don't have a printing method. Point $, point X, point Y, does not belong to the wire. Wait. Have I plotted the stuff out though? I think I have. Yes, I have. Point not belong to wire exception. Point tangle point. And distance, all good. So if I write now, it'll say that, so I might have messed up my tests instead. I have not. To be 2 but found 4. Mystery. -2 and 2. -1 and 0. Okay, -1, -2, -3, -4, 1, 2. Well, that's correct. I think it's logical mistake, kind of, mixed with something that I missed. -4, -1. So I will start at -1. So it will go like this: -1, -2, -3, -4. And then it will go up by 1. It should be 5. Why is it not 5? What? How can it not be 5? -1. minus 1. That's the first point. And then it goes to minus 2. And what's the total path? Minus 1, minus 2. Minus 2. Minus 2, 2. So it literally should be 4. How can it count 5? It doesn't make sense. How can it, what doesn't make sense? One, two, four points, distance is 4, minus 2 equals the tangle point. It's exactly saying what I wanted. No. It returned distance, which is 4. I didn't expect it. Minus 2, 0. Oh my god. I didn't pass the point. Jesus Christ. Run. Okay, run. So now I'm confident that this works. And now I'm scared why this one doesn't work. Expected 410. Total signal steps less. Let's see what happens. So first length 16, then 15, 31. Why? What tangle point are you taking? 6 and 5. X is 6, Y is 5. Manhattan distance 11 to the origin. Okay, back. Let's see what happens. Six and 5. What's the distance to 6 and 5? 21. So 1, 0. Crap. I will need to be going soon, but I'll be back as well soon. 1 0 2 0 3 0 4 0 5 0 6 0 7 0. I'll actually open the task to follow it along. I don't need this. One 0 2 0 3 0 4 0 5 0 6 0 7 0 8 0. Where's the continue button? Eight 0, and then it should be 8 1, 8 2, 8 3, 8 4, 8 5, 8 6. Four, 5. Huh? 5 5 6 5 0 1 0 2 3 4. What? Seven? I'm looking at the wrong one or something. Seven. What? 6. How is it jumping like this? What happened? How can the path suddenly jump? 2 7 3 7 4 7 5 7 6 7 6 4. Oh. 6. Okay, this is really bad. Why do I have not plotted points at some point? Plot. Expected distance. Panel tests. Show me all tests. Wire tests. Or was it line tests? Plot. I still can't get it. Why is it jumping in input in the plotted value? Why is my wire so weird? This one is fine. This one is also fine. I'm checking wrong test. I need to check. Yes, this one. The one that fails. What the hell? Which one fails? Panel tests. Expected distance to be 45, but found 31. Why did it jump? Or is it not in order? A path is IList, and IList preserves the order. If I do for each, I preserve the order, don't I? This one is boring. This one is too complex. And this one is the one I want. So 24. First off, both wires have the same amount of points. How come? 0, 1, 0, 2. That's fine. One, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 8, 1, 8, 2, 8, 3, 8, 4, 5, and suddenly 4, 5. How can it plot it like this? It just makes no sense. Eight, 4, 8, 5. 4, 5. How can it jump by 4 units? Okay, what's the position at 8, 5? So it went 8 units to the right. And then 1, 2, 3, 4, 5. Right? And then what? And then suddenly 4, 5. And then suddenly 4, 5. 1, 1, 2, 3, 4. 4, 5. And then 3, 5. 4, 5. 5, 5. Eight, 5. 4, 5. 5, 5. 6, 5. 7, 5. It didn't preserve the order. I see. So I plotted correctly, but from the wrong end. It plots from the wrong end at some time. And why is it plotting from the wrong end? That is a mystery. I should go to a line test and see the plotting function, how it's been done. I think this bit is a bit stupid. I should always plot from start to end, no matter what. Always. But now I'm plotting from smallest to biggest. Why am I doing this? I think this is a major logic mistake. So Be right back. Okay, I'm back. So this part is bullshit. Why is that is correct? But this part, why am I comparing them? I really don't know. It should have been this. As simple as this. So, not needed, not needed. Comments are already deprecated. And same here. Not needed, not needed. Start.y. End.y. And point, add, and points. Run all my tests. Oh. Plot. Wire tests, panel tests. I had some presumption somewhere, and that's why it's failing. Run tests. Let's see which ones are failing. Wow. Plot. Line tests, plot them between 2 points. Okay. Okay. So what happens? Shortest distance to origin. Find tangles. How does it find tangles now? By intersecting paths. 1, 0, 1, 1, minus 1, 1, 0, 1, 1, 0. Oh God. Paneled path to panel config. So it fails at finding intersection, but why is my plotting function now faulty? Okay. I can check it. Okay, so I have this and I have this, and given both 1, 0, 1, 1, 1, 0, 1, 1, minus 1. What? Path. Right, up, left. Right, up, left. And my path is supposed to contain one more, but it doesn't. Okay, I see what's wrong. I cut the edges too fast. That's why it fails. It's a line test that fails. That should fail, actually. Plot. I see what I did. It should have been yeah. If it's negative, it will not put the point and it will stop. So I need to determine if it's more or less. And the answer is that I don't care. So I take absolute values of both. Like this. Math ups y, math ups y. Perfect. So a real TDD would have been done like this. You spot a bug, you write a test for it. And the bug is that one more case, like this. Here, I move to the right and up. What if I move to the left? So that's the case that I should have put. From 0 to -2. So what happens is that it becomes -1. Well, 0, 0, -1, 0, -2, 0. And if I run, this case should fail. And so I go back to the here and I fix that. And if I run again, it still fails because it should have been inclusive. Shouldn't it? Y plus 1? I don't remember. Oh. Y plus 1 doesn't make sense. I don't understand why +1. I take the first point from both, plot it there. Now all tests will fail except this one. All tests fail. So I do need +1, but why? And this is not true. Math apps is not true. Because sometimes I take away stuff, sometimes I plus it. Yeah, totally. So and they will switch places. How do I determine the condition? Enumerable range. Start end. That's probably what I want. So I want all numbers in that range. Start count. No. Wait. Well, it will be incremental, so no. How? Also, I don't know if it's x plus or minus. But the start point was correct. This I need, this I don't. Yeah, the algorithm was bad for plotting. Okay, I think I know. If this is this, I don't need those two. I need that one. So no, that's not true. Var index, var increment is if it's like this, then increment will be -1. But I also need to compare them accordingly. Else 1. And comparison will be comparison. How can I compare in one unified way? Oh. I don't do this while 4 is in between, but while I have the points in between. And my increment will dictate a direction. So bar points is var count will be start x minus end x, absolute of this. And this is not needed. And so I will start at x. Why did I start at x plus 1? And why do I add end in the end? References, I want to see. Plot, because I add origin point. Right. Well, first things first, let's make this logical. Y starts at here, increment is this, count is this, all is good so far. So let's say 7 points. We start from x, I think, is more justified. And our x should be less than end x. No. And we don't start from x. We start from 1. Maybe that's why 1 is coming from. Maybe, I don't know. And we end. Okay, we start with 0, so we take the point inclusively. And then we say x less than end x, x plus plus. No, not end x, but count. And x plus plus, all good. And we take start x plus x and y, and we add it. And we don't know if we increment or decrement, so increment is this. And we do the same here. Increment is basically this. It cries for refactoring. I know. -1, 1. No need. Count. And this is actually refactorable, it seems. Y. And I say start Y. I say this. Y. X. Sorry, X, Y. Let's see what happens now. Terminate, missed the condition. Increment will be 1. But here I will multiply it from increment. Multiplier. Increment will be 1, but I multiply you from this. So it's negative or positive. Expected plot to be a collection with 3 points, but 1, 2, 3, 4. 0, 0, 0, 1, 0, 2, 0, 0, 0, 0 again. Where's the first point? Oh, I take the start point. Okay. Expected item 1 to be what was that? Why? But found 1, 0. Wait, so this one worked with one direction, but didn't work with the other. Because I only had... One, two, three. 1, 2, 3, 4, 5. Where are the 5 tests coming from? I'm looking. Okay, I see the mistake. Like this. Let's run again. Because I multiplied wrong thing. Good. Let's run my test and my whole thing now again. Almost. One lousy test. Expected distance to be 4 to 5, but found 30. For the trivial one, and for hard ones it succeeded, strangely. Wait. It is not 4 to 5. It's 30. Oh yeah. Okay, perfection. Third. Run my tests again. Perfect. And let's wrap this up. Challenge 3. Demo 2. Input. This is a bit messed up. This is challenge 2, this is challenge 3. So I'll write 33. This is challenge 3. No, this is challenge 2. This is challenge 3. This is challenge 2, not 3. And this is challenge 3, not 2. And change. Perfect. And demo 2, very similar. demo 2, panel, new panel, input, new wire untangler. Yes, nope, yes, closest distance, signal sum to closest signal sum, intersection sum, I'll call it that. Really bad name, but nothing a good comment can't fix. Calculates sum of finds the smallest, calculates and finds the sum of two of intersection of both wires, which results in the shortest path, signal path, to travel for both. Good. So if I go to challenge 3, program, full demo, and run it again. The answer is this. That's not correct, that's not correct. Wait, did they change the input? Did they? They didn't. Yeah, input doesn't change. Well, I thought I was done, my tests pass, I took the example stuff, but it doesn't. It seems that it doesn't. So, yeah, weird. I used TDD, so they did have tests, which is tests that run are tested. Kappa. Yeah, basically the way it works, it's actually quite simple. The way it works, I take, I find all the tangles, that works, confirmed, and then I calculate length, so I then loop through all the tangles, and I take a tangle and I calculate distance or steps that need the signal to travel from origin point to that tangle. That's tested and it works. So I get distance to a first tangle for wire 1, then the same for wire 2, and then I take the sum. And if the sum is less than the one I have, I say that it's the smallest sum, the closest distance, and then I return that. But it didn't work for some reason. Maybe what I called was not correct. Demo2 input seems to be right. I calculate closest distance. Is too low. You guessed this much. My answer is too low. And the way I calculate distance is that I first plot. So when I create a wire, when I initialize a wire, I take those distance thingies, which looks like this. So I create a wire. No, not there. I parse a wire. When I parse a wire, I... yes. So when I parse a wire, I first get coordinates of corners. Then I create lines in between those corners. I call corners like the points where it moves, changes direction. So then I plot that to a grid. So I plotted 1 point each. And so a wire is just a whole bunch of points, no longer directions. And then when I get corners, I intersect points of two wires. So when points match, they are the intersection points. And this is sparse. And that's about the wire. The entangler, like I said, the intersection is what tangles are. Closest tangle is the smallest intersection. First one ordered by distance in descending order. And I don't know why I did this. If I could have just done min, probably. And that's a good point. Hashtag refactored. Oh wait, I need that. Okay. Find tangles min. Okay. Or min. Run, see if I didn't break anything more than I should have. Okay. Oh, my Manhattan distance, I forgot. But it probably, well, whatever. It probably takes that, yeah. Closest tangle. Closest tangle. Okay, makes sense. Order by. Makes sense. Okay, run, pass, continue. So where could I have gone wrong? Just in case. Can I input the previous one somewhere? Puzzle input. I don't think I can paste it again. God damn it. Reach the intersection. No, it's fine. I want to figure it out myself. Wait a minute. Challenge 2. Challenge 2. Challenge 3. False hope. Tangled wires, wire untangler. Calculate signal to intersection. Okay, let's think logically. It does find intersections. That has been proved because the first one worked. Now the second one, the distances. It does calculate distance correctly as well, in most cases. And I don't understand how is it not covered by these two. It should be. So it is able to calculate the distance from origin point up to the tangle point for every wire, and then the sum. Wait. Minimize the actual signal delay. To do this calculation, the number of steps each wire takes to reach each intersection. Yes, I do that. Signal steps for both. Total signal step closest. I take it. Length to a point is just moving one point and calculating distance. And when I reach the point I want, I stop. Why is it not saying if it's smaller or bigger now? Doesn't matter. Fuck. Where did I R? Where did I R? Can I just click on the first one? I really want to submit the first one. Is there history or something? Oh, here. 1431. Do the samples pass? Yes, they do. If you look at this, I input those two. And if you look at my tests, panel tests. So here, this one produces 610 and this one produces 410. And as you can see, I take those two. And if I run this test, it passes. This is why it's so weird, because what edge case did my logic not cover? And the test is taking the text file name and the expected distance. And from the text file, I create a panel multiple times. How can they be hit multiple times? They're not considered. But how can I hit points multiple times? I mean, if I travel to point, wires can go over previous spots. Well, in terms of that, it shouldn't be considered. You see, the way I calculate it, it travels across the wire path, across the grid, point by point, and when it reaches the tangle point, it stops, and that's the distance. So I think in theory that is covered. That shouldn't be missed. Because, yeah, if it tangles, it should still cover. We can make a test for it, sure, though. Tangled wires, loop. So we go, let's draw it. Let me bust out my paint. So what I want essentially is something like this. Something like, and that it would be inside a tangle. I would think that returns should deal with overlaps. Yes, but I think mine does, I hope. That would definitely cover it. But maybe it needs to be inside the overlap. Like this. And the other one going like this. And the other one like this. So the point is here. The closest one. Or there. Or it's the same. It's actually the same. Anyways, let's model that. This is the scenario you meant, right? I think it's what you meant. So the first one goes 5. Are distances being summed? Yes. Yes, they are. Basically, when I calculate the length, I traverse the points and sum. Basically, each point is, the distance between one point is 1, so I sum it like this. And in the end, I always have a sum of distances between those two. I plot the points like this, and actually plotting was an issue before. So I have a test for plotting. So basically, if I pass point 0, 0 and point 0, 2, the plot will be 0, 0, 0, 1, 0, 2. And the way I generate it is like this. I say if, so I first create a line. So this is a method of a line. Line is 2 points. And I say if line is horizontal, that means y is constant. And then I say I have a multiplier. And then I say that in that line there will be this many points, because that's the line distance basically. And then I say that for, so I start the line, the plot with the first point already added, and at the end I add the last point, and in between I add those points. So I add point like this. So let's say in our case 0, 0 and 0, 2 means line is vertical. So I would add first, this would be 1, multiplier is 1 because it's positive. Then count would be 2 because 2 minus 0 is 2. And then point would start from 1 and end at 2. So it would add a single point in here, and that would be 0. Start is 0 plus 1. So it would add 0, 1. So it would add 0, 0, 0, 1, and 0, 2. That's how I calculate the plot for lines. That's how I generate points. And then when they come to a wire, inside a wire, there is a whole bunch of those points. Oops, not here. Points. So when I have a wire, again, not this, here. So when I have a wire, it parses the literals into points. So it takes the origin point. So I first parse the corners, that's trivial. And then I say, I take the origin point and I first get line from the origin, and I plot the points of that line, and then I plot the points of all other remaining lines, all the other fragments in the wire. And then I remove the origin point because it's not relevant in calculations. And just in case, I removed the overlapping points. I remove overlapping points. Uh-oh. Uh-oh. That is a big problem. Okay. I think we found our issue. Yes. Now let's make it not as guessy as it was. Parse. So I first get corners, then I plot them. And the problem with how I do it is that this will include, the next line will include all points from the previous line as well. So the end will overlap. So what I need to do I need to remove the endpoint before I start plotting every time. So in my plotted points, I should remove the endpoint. And I create a line and I plot it again. I create a line, I plot it again. But I remove the endpoint of the previous line, so my points no longer overlap, I think. Nice. Nice. Wow. Okay, it's different. Oh my god. Oh my god, thank you very much for helping me out with hints. Holy shit. Thanks. Thanks a lot. Jesus. How could I miss it? Why did I go for a shortcut in the previous one? And the fucked up thing is that in the previous scenario, that wasn't a thing, that wasn't even necessary. Jesus. Holy shit. Awesome. Okay. Let's git commit and be done with today. Thanks a lot, seriously, for rubber ducking the shit out of me. Okay, challenge 3, challenge day 3, part 2 complete. Let's refactor something because I have some really bad parts. Like the line thing is completely redundant. Let's think what we can refactor. So I can get a target. No, I cannot get a target. No, I don't think I can refactor. Do I use this? Jeez, this is horrible code. I don't... Wait, this is just a test. I don't use this. Because the points intersection is literally LinQ, not anymore something that I made up. Okay, awesome. Removed some code. I cannot clean this up. Let's look at what I have. Line, orientation, panel, point equality comparer, wire. Still not really dirty, honestly. Yeah. Alright, but seriously, such a great point about a loop, forgetting a loop, like when it goes around, because the way I calculated was that I forgot those loops. So when I plotted my things, it would give a completely bad answer for those loops. And actually the distance, getting the closest intersection point, well, it didn't matter at that time because it was still the same points, so whatever. All right. Removed unused code. Push. Thank you all for watching and see you next time, guys. Bye bye. I'll stream tomorrow as well, so see you.